Today we're going to talk about one of the most common, one most used features, one most fun things to do in algebra, and that is to factor. All right, so it's really a great way to learn some number sense and some manipulation of variables. And so let's look at what we're doing. We're going to factor a lot of different ways here. So on number one, I want to just start off and show you what happens here when we are multiplying. Okay, so on number one, this is just the distributive property. It says find the product. That means multiply. So to do that, I'm just going to distribute. All right, so what I'm going to end up with is a 42n squared minus 28n. All right, on 2, same idea, just distribute. I'm going to have a 12b to the 4th minus 6b to the 3rd. Now, that's not factoring. That's multiplying. Factoring is the undoing of that. So what we're going to do is I'm going to give you the end product, and I want you to figure out what is the common factor that you could pull out of that. So like in this case, it's the 7n. I have to look at these two numbers, and I have to say, well, what goes into both of those? 7, all right? And as far as the variables, how many n's could I pull out? Well, remember, since it's coming from this distributive property, it's going to have to be able to go into both of these. So I'd bring out as many of them as I can that each one could represent. Okay, so looking on number 3, what's the number common factor? What goes into 8 and into 4? And you should say, oh, well, 4 goes into both of those. So I'll factor out of 4. And then I look at my r's and I say, well, this one has 4 r's, but this one only has 1. So I bring out, basically it's whichever one has the fewest. So I'm going to bring out just 1 r. And then you write what's left. Okay, so remember, factoring is basically undoing the multiplying, so it's dividing. So 8 divided by that 4 that I pulled out is going to get me a 2. And I have an r to the 4th divided by an r is really going to be an r to the 3rd. Minus 4 divided by 4 is a 1 r over. So basically that I pulled that whole thing out, but I do have to leave a 1 there. And you can always check your answer by coming back and trying to distribute that and seeing if you end up with that factor. Okay, let's try number 4. Let's do it again. I look at that and I say, what's the common factor that goes into 10 and into 20? That'd be a 10. And then how many x's can I pull out? Well, I pull out whichever one has the fewest, so it's going to be an x squared. And so 10 divided by 10 is 1. And the x to the 4th, but I pulled 2 of them out, so I still have an x squared left. That 1 is optional. We typically wouldn't write that unless that was the only thing there. Minus 20 divided by 10 is 2. It was an x squared, but I pulled the x squared out, so that's all I've got. So we're just practicing kind of this idea of pulling out a GCF. Let's look at number 6. There's 3 terms on this one. That's okay. You're just doing the same thing. You're finding the common factor that you have throughout all of those. So if you look at that, it looks like a 2 is going to be my biggest number. And then when you look at your n's, it looks like the one that has the fewest is the n squared. So I'm going to pull 2 out of all of them. So then what I'll have left is a 10. There were 4 n's. Now there's only 2 left. Plus 4 divided by 2 gets me a 2. It was an n cubed, but since I pulled 2 of them out, there's still just 1 sitting there. Plus 6 divided by 2 is a 3, but all of the n's got factored out. All right, and then let's try one more thing. Let's look at number 8, because it has different variables, and it has more than one variable. All right, so the idea is similar. I'm going to look at that and say, well, as far as the 12 and the 6, I could pull a 6 out. And then I look at how many a's can I pull out. Well, the first term has an a cubed, but the second one only has 1 a there, so I'm only going to be able to pull 1 out. As far as the b's, well, same situation. I can pull 1 out. And so then what's left? 12 divided by 6 is 2. We had 3 a's, pulled 2 of them out. I'm sorry, pulled 1 out, so there's 2 left. Same deal on the b's. And then again, remember, if you happen to pull everything out, then you just write a -1, kind of as that placeholder, and you've got it. All right, why don't you try number 5 and 7, pause the video, and then come back. Okay, how'd you do? Check those 2 answers. The one thing I want you to notice on number 5 is we do typically, if that leading term is a negative, we'll pull a negative out. You maybe didn't, then your signs would have been the opposite of mine. I wouldn't get super picky about that, but typically we would pull that negative out if that's the leading term. All right, so that's the first type of factoring that we're going to have, is just pulling out the greatest common factor. And you really always want to start with that, because sometimes you can go further, but you always want to start with your common factor. Okay, so let's go back to multiplying now, and let's look at what happens instead of just distributing, but we're taking a binomial times another binomial. All right, so to multiply that, we're going to use FOIL. And so let's multiply first together, 3m squared. Outer gets me 9m. Inner is -1m, and last is -3. And then these middle 2 terms typically will be like terms that we can combine. Okay, so do you remember doing that? All right, let's try it one more time. We multiply the first, that gets us 20a squared. Outer, inner, and last. Combine the like terms and get your trinomial. Now that's not actually what we're going to focus on so much today. It's really the undoing of that, the factoring. Remember that multiplying and factoring are opposites. So if the factoring is trying to take you from this trinomial back to the 2 binomials. Okay, before we jump into that, let's do one more thing with this multiplying that I want to focus on. Whenever we take a binomial and square it, remember that that's like 2x minus 4, and you're going to take it times itself, and then you do FOIL. So first, outer, inner, last. Combine the 2 terms in the middle. All right. Now let's look at this other one. I'm going to do the same thing, but I'm just going to show you what the answer is. All right, so I just did the FOIL real fast there just to kind of hurry us along. What I want you to notice on these 2 problems is what happens on these middle 2 terms. Do you notice that when you do the outer and the inner, you get the same thing both times? Okay, that's because you're taking the outer times the inner, and the, or really, yeah, you're doing the outer and then you're doing the inner, but they're the same numbers that you're multiplying. That's always going to be the case when you take a binomial and you try to square it. That will always happen. So what I'm looking to do is maybe look for that pattern and create sort of a shortcut for that. We will do this where we have to square a binomial a lot this year, and so the number one thing that I want to make sure that you don't do is try to just distribute this squared and call that 4x squared plus 16, because notice we do have these middle terms. Those don't go away. If you just try to distribute that squared, you're going to totally miss this middle term, and we don't want to do that. Okay, so above all else, don't forget that. Secondly, let's try to use this shortcut. If I always know that these middle 2 terms are going to basically be, in this case, the 2 and the 4 being multiplied together, or in this case, the 6 and the 5 being multiplied to get the 30. Okay, so really, I don't need to write this all out. Couldn't I just say, well, my middle term is going to be, and just multiply these 2 together? There's a -8x, but I know that there's going to be 2 of them, so I would just double that, and that's where I could get a -16x. Same thing here. Can't I just multiply these and say that's going to be a 30r, but I'm going to have to double it because I know there's going to end up 2 of them, so I'd have a 60r. All right, and the first and the last terms just come from squaring each of those. So there's my 36r squared, and there's my 25 just by squaring those. Okay, so with that, we really should be able to jump from this problem clear down to here without showing all of this work. At this stage, when you have done this for as many years as you can, now is when we start looking for some of those shortcuts. So let me try one just doing the shortcut. Okay, so I'm going to square the first term. That's a 9x squared. I'm going to multiply those two, which is a 6x, and then double it. So I know it's a plus 12x. And then I square the last term, and I get a plus 4. Okay, let's try one more time. Square, I'm going to do 15 here. Square this first term, so that's a 4n squared. Multiply the 2, negative 10n, but you got to double it, so negative 20n. And then square the last term would be a positive 25. Okay, you try 14 and 16. Pause the video. Okay, hopefully that's what you got right there. So from here forward, that's how I'm going to square those binomials. I'm going to try to use that shortcut. So you try to do that too. Use your shortcut. Okay, so our focus today is actually more on the factoring part of this, more so than the distributive property and the FOIL that we've got. But the factoring is the undoing of that stuff. So it's kind of good to review that first and then come back and look at how do you undo the FOIL? How do you get back to those binomials? So let's practice our factoring skills. First thing we want to do is always remember to look for a GCF first. So if you look at number 17 here, I'm going to look for a GCF that will go into that. 5n is my GCF, so then I would have left an n plus 6. Now sometimes that's all there is. You pull out the GCF and you're done. This is an example of that. What I have left here in this binomial is considered a linear factor because it's n to the first power. If you get it to a linear factor, then you're just done. Don't try to do more than the GCF. Okay, so let's go to 18. This one does not have a GCF in it. So I'm going to just jump right in, and basically what I'm doing is I'm taking that trinomial and I'm trying to take it back into the two binomials that would FOIL together to get that. Okay, so remember that your first number right here comes from first. Your last number will come from last. So let's start putting in some of those. First is going to have to be x and x, and last is going to be something that multiplies to 20. The problem is here that or negative 20. We have multiple options here. You could use a 4 and a 5, a 2 and a 10, a 1 and a 20. So you have to remember that you're also wanting to end up with this when you do your outer and your inner. They'll combine to get you the 8x. So when I look at this 20, what I'm really doing is I'm looking at factors of negative 20, things that multiply to negative 20, but will add up to 8. Now, since that's a negative 20, I'll want one number positive and one number negative, so they'll end up having a difference, because since they're different signs, of 8. So that's going to end up being my 10 and 2. Only since it's a negative 20, one's positive and one's negative. Since I want to end up with a positive 8, I'll make my bigger number positive, and then that's a negative. And so you can always check that. That'll get you a 10x. That'll get you negative 2x. There's your 8x that you want. So we've got our factors. Okay, let's try again. Number 19, there's no GCF. So we'll have an x and an x. And then we're looking at factors of 18. This time it's a positive 18, so our signs will have to be the same. And we'll want them, those two, whatever factors we pick, we want it to add up to 11. So I think that's going to be 9 and 2. So if I put in my 9 and my 2, but notice that I want this to end up adding up to a negative 11. So instead of making these both be plus signs, I'm going to make them both be minus signs. That way I'd have a negative 9x and a negative 2x. And there's my negative 11x. Okay, number 20, I want you to pause the video, try 20 on your own. Okay, so on this one you should have had an r minus 5 and an r minus 6. Your signs were going to be the same because this was a plus sign, and they're both going to be minuses because you're looking for a negative 11 on that. All right, let's look at some harder ones. Okay, so now we're going to look at some of these trinomials that have a leading coefficient of something other than 1. That starts to get a little bit trickier. And I'm going to go through this like this is just a review, and I'm just refreshing your memory on this. If this is something that it's not coming to you and you don't remember doing this and you can't do it pretty quickly, I highly, highly, highly recommend you go back to the list of tutorials that I have for you and go back up at the top where it says, I forgot how to factor, and watch that one. It's a little bit more basic. It kind of goes back to the beginning and walks you through the steps a little bit more slowly. You can watch this. If you find out this isn't ringing a bell, then stop and go watch that one instead. Okay, so here we go. On 21, the very first thing we always do is look for a GCF, so I'm going to pull out a 2. Okay, now I'm going to look for factors of 72 that are going to add up to 17. I actually got lucky by pulling that GCF out. I'm back to a coefficient of 1 here. So this is just like what we had done on the previous slide. So factors of 72 add up to a negative 17. Okay, so they have to multiply to 72. That's going to be my 8 and a 9, but I want it to be a negative 17, so I'll make them both be negatives. A and A. Got it. Okay, that one really wasn't too bad because I got the leading coefficient down to a 1. Let's try number 22. On this one, there's a GCF. I believe 6 would be my GCF, so I'm going to pull a 6 out. And then I'm going to have 3x squared plus 2x minus 16. All right, now I did pull out a GCF, but I still did not manage to get this coefficient to be a 1. If this is not a 1, this is not near as straightforward. And so you may have learned different ways to do factoring. I pretty much like just the guess and check of, using some common sense at picking your factors and being familiar with how those numbers work together. Okay, so first, since it's a 3, it's going to have to be a 3x and a 1x. 16, I could choose 4 and 4, 2 and 8, 1 and 16. They are going to be different signs. Since I want it to be a negative 16, I'll have one of them a plus and one of them a minus. And somehow or the other, I'm going to want my outer and my inner to end up being adding up to a positive 2. All right, so if I want one of these numbers to be a positive and one of these to be a negative, and have the 2 add up to a 2, then this outer and inner have to give me 2 numbers that are relatively close. So for instance, I would not want to put an 8 and a 2 because that's going to get me a 24 and a 2. Those aren't close together. That's not going to be helpful to me. So let me get rid of that. I could swap it though, because what I could do is I could put my 2 here and my 8 here. Now what I end up with is a 6 and an 8. Okay, those are closer together. In fact, that's exactly what I want. That's a 6x and an 8x. Okay, but remember that one has to be positive and one has to be negative. So since I want to have a positive 2, I'll make my 8 be positive and my 6 be negative, which means I'll put a negative there and a positive there. Okay, so I kind of approached that with some pretty, some number sense on how those numbers would fit together the best. Sometimes it takes a little bit of guess and check, and maybe you would have tried your 4 and 4 and it didn't work out, and so then you had to try something different. Sometimes it'll take a little bit of time, sometimes it'll come to you quicker. All right, 23. Again, GCF first. I'm going to pull out a P, and then I'll have a 2P minus 5. And then actually there's another one. Look, I pulled out the GCF. I'm left with a linear term. I'm done. Nice when those pop up. Okay, back to 24, back to reality here, looking for a GCF to pull out. And there isn't one. Okay, so this is definitely going to have some bigger numbers that I'm going to deal with. Okay, so on this one, I got factors of 9. So that could be 3 and 3 or 1 and 9. And then on my 6, I could do 2 and 3 or 6 and 1. So I have some options there of what's going to happen. Now, keep in mind that my signs are going to be different again. And if my signs are going to be different, I'm going to have one positive number and one negative number and somehow have that add up to a negative 25. Okay, that means that there's going to have to be a big difference between these two numbers for them to add up to negative 25. So I'm going to have like a huge negative number and a little positive number. Okay, so when that's the case, that leads me towards using my more extreme factors like my 9 and 1 instead of my 3 and 3. That way I can make a bigger difference faster. Okay, so what I'm going to do is I'm going to go ahead and start with my 9x and my 1x, and let's see if that will work. Now, I could also do the same thing with the 6, and I could go with those extreme. That might be a little too much, so let me go with a 2 and a 3, and then we'll see what happens. All right, so I'm going to put my 2 and my 3 in here. Remember that one has to be positive and one has to be negative. I'll work on which one's which here. I may have to change that if that didn't work out, but here we go. Negative 18, positive 3. That is not going to get me a negative 25. Let's try again. Let's swap the 2 and 3. And if the swapping doesn't work, that means I goofed up on my factors, and I'll just try some different ones. So let's put the 3 here this time and the 2 here. So now when I do outer, it's a negative 27 and a positive 2. And that adds up to a negative 25. I don't even have to mess with my signs. I got the right signs even. So there we have it. It worked. Okay. Don't be afraid at this point to go back and watch that other video that breaks it down in steps a little bit more slowly for you, and you can watch that instead of this one. Okay, so what I'd like you to do is try 25 and 26 on your own on this one. So try doing these, try your factors, see if it works, trade them out, change your signs, do what you need to do. You pause the video and try these by yourself. Okay, so I'm going to go ahead and walk through my thinking process on this. So on this first one, I'm looking for factors of 4 for first, factors of 36 for last. I want my numbers to have a difference of 7, so they're going to have different signs. One will be bigger, one will be a little bit smaller, and I'm probably going to go ahead and I might try 2 and 2. No, you know what? I think I'm going to go 4 and 1. 4K, 1K. And then for my 36, and like I said, you're going to get better at this to where you don't have to write it every time, and so you can just think through it in your head. If I put a 6 and a 6, I'd have a 24 and a 6. That's not going to get me a difference of that. And so I'm going to go with my 9 and 4, probably might be a better pick. All right, and so I don't want to put a 9 in this spot because I feel like that's going to get too big. So I'm going to put the 4 here. So 4 there and my 9 there. That gets me a 16K and a 9K. And remember, it's a negative 36, so one of those is going to be positive and one is negative. And this is actually going to work great because then if I have a positive 16 and a negative 9, that'll get me my 7 that I want. Okay, so that means if my 9 is going to be negative, I need that to be a minus, I need that to be a plus, and I've got it right there. All right, on 26, on this one you're going to pull out a GCF. Now, I was hoping for something better, but I think my only GCF on this is going to be a 2. So if you pull the 2 out, You have 9x squared minus 36x plus 32. Now this is a great example of why I know that one method that some teachers choose to do factoring is to multiply this leading coefficient times this constant, and then you're looking at factors of that number. But and that works nice when you're first starting, but we're going to probably get into some of these trinomials that have some pretty big numbers in them. And so a 9 times a 32 gets to be pretty big and kind of prohibitive to try to come up with factors that are going to work. And so that's why I'm not really doing that. It's called the AC method, why you would multiply the A times the C. All right, so let's look at what we would have on this one. All right, I'm looking for numbers that are going to add up to this 36. So my signs are going to be the same. I want it to add up to a 36. So, you know, that's not huge. So I probably am going to start with the 3 and 3 for my 9. So 3x and the 3x. And factors of 32, I could go 8 and 4 or 6 and, or 8 and 4 or 16 and 2. I'll probably do the 8 and 4 because I want them to add up. All right, signs are the same. Oh, they're both going to be minuses so that I end up with a negative 36. There's a negative 24, negative 12. Yep, there it is. That's a negative 36x. Okay, we got it right there. There's your factors. Okay. And then the last thing I want to talk about, those are a couple of the special types of factoring that we do. So one of those is called a difference of two squares. And that's actually probably the quickest, easiest type to factor. And what it basically is a difference, meaning you're going to be subtracting, and these are both perfect squares. Okay, if that's the case, basically what you're missing is the middle term. There's no x term. So what you're needing are factors. So I'll set this up. I'm going to have my x and my x, and I'm going to want factors of 16. One's positive, one's negative there, that are going to get me a 0. So in order for that to work, these are always going to be the same factor, which is always going to be the square root of whatever that number is. So the difference, though, is that you want one of them to be a plus and you want one of them to be a minus. And that's the way difference of squares always factors. You take the square root of this number, you take the square root of this number, you have one plus and one minus. All right, here we go. Let's try this one. Oh, wait. First thing I need to do is pull out a GCF. Let's go ahead and pull out a 4 on that one. Then you'd have an m squared minus 4. And what you have left is a difference of squares. So I'm going to have the 4. And then remember, you square root the m squared. That's going to be an m and an m. Square root the 4 is a 2 and a 2. One's a plus, one's a minus. Okay, you try 29 and 30. Pause the video. All right, so check yours, see if you got the same thing that I got. If not, go troubleshoot, see where you went wrong. All right, here is our last thing that we're going to do, and it's another special type of factoring. And this is when you have a sum or difference of cubes, not of perfect squares, but of perfect cubes. But this one works if it's a sum or a difference. If you're doing squares, it has to be the difference. All right, we use this little acronym to help us remember how this sets up. But it's basically just, and if you want to jot this in your notes or whatever and call this, it's called cube root, SOPs. Okay, so what's going to happen is you're going to do a cube root, and that's going to be your binomial. And then you're going to get a trinomial from this. So it doesn't factor to two binomials like we've been doing. Okay, and now what these letters stand for, this means that you're going to square your term. This is going to be the opposite sign, and I'll explain this all as we go. This means you're going to find the product, which means you multiply. Remember, the product is what you get when you multiply. This is always a plus sign, and then you're going to square it again. Okay, so here we go. Number 15, we have a difference of perfect cubes. So it's going to factor to a binomial with a trinomial. And then we cube root. So that's going to be an x, and that's going to be a 5. And this is a minus sign always. It always is going to be the same as whatever is in the problem. So cube root, same sign, cube root. All right, now let's do SOPs. Okay, when you're doing the SOPs, you're always referencing back to this binomial. So the first thing I'm going to do is I'm going to square whatever I had in that first spot. So I'm going to square my x. So that'll be an x squared. And then the O means use the opposite sign. So right here, whatever that is, you're going to have the opposite sign here. So that means I'm going to have a plus sign. Okay, next thing is the product. That means you multiply these two things together. Now, ignore the sign because we've already got the plus sign there. And in fact, that's always going to be wrong. So you just multiply these two, and that gets you a 5x. Okay, and then the next P means plus, so we put a plus sign. And then last S is square it. But instead of squaring the first term, we're going to square the last term. So for me, that's going to be a 25. Since you're squaring it, that should make sense why that's always a plus sign on there. Okay, so that's all there is. You just have to remember that little acronym and then fill it in. Let's try it one more time. This one is a sum of two cubes. So do your binomial, then your trinomial. All right, cube root, so that's a 2. Keep the same sign, and that's going to be a 5a. Okay, now we do SOPs. Square the first term, opposite sign, find the product, put a plus sign. Now square that last one. So that'd be a 25a squared. Done. It's really, once you get to know the acronym, it's probably the easiest one we've got. All right, that's all I have for you on factoring. Good luck.